Our next topic is atmospheric refraction. Okay. Now, how does atmospheric refraction take place? There is one atmosphere. So, how does refraction in that occur? See, imagine this is our Earth, and there is atmosphere surrounding it. Okay. Now, as we all know that we live very close to the Earth. Okay, we live on the Earth's surface, the human beings, and there are various industries and all which are producing so much of dust, so much of pollution in the air. So, what happens ultimately? There are different layers of atmosphere being made with different densities, like this. Due to this different densities, they will have different optical densities. Due to different optical densities, the light when entering into the Earth atmosphere will be passing through different layers of atmosphere with different densities. So when light ray is say incident on this, okay, enters. Now as here we have space, so this is the most rarest thing we can have, space. So this layer will be denser, this will be little more denser, this will be little more denser, denser and yet denser. So what happens when white light enters into the atmosphere? It enters from space to a denser medium, so it will bend towards the normal. Again it will bend towards the normal, again towards and towards the normal. So ultimately when you are standing here, the light ray which comes to you is straight only for this part, and you seem the image of this object to be seen here. This is how atmospheric refraction takes place. Okay. So ultimately due to this atmospheric refraction, various phenomena are involved and which take place, and that is what we are going to study in our next topic as atmospheric refraction, and we are going to see what all other phenomena occur due to atmospheric diffraction. Now as what I explained you, the same phenomena takes place which is responsible for twinkling of stars. Okay. Again I will draw the same diagram for you and try to explain you. Say this is Earth and this is the atmosphere. Okay. Now due to different layers of atmosphere, as I explained you, what happens? Suppose there is a star here whose light enters into the atmosphere towards the normal and towards the normal. So ultimately the straight path which is only this much is seen to you, and an virtual image of this star is formed here. So the star that you are seeing now is not actually at that point, it is somewhere else. Okay, so this is just its image, right? Also Earth is not stable, right? It is continuously in motion, constantly moving. Now along with it, so a particular ray of light would not come to your eye for constant, say 1 minute, 2 minutes or 10 minutes. It will change every second. So the image of this star which you are seeing here keeps on changing its position. So say for example the instance you saw a star, the other instance its image is formed somewhere else because of motion of Earth. Along with it, in the atmosphere there are clouds which may come in between when the images are formed. So to your eyes, for your eyes, the the image of the star is sometimes formed, sometimes not formed, sometimes formed, sometimes not formed. And because of that, it feels as if the star is twinkling. But actually, the star do not twinkle. We know sun is a huge star, but it doesn't twinkle. Right? So other stars also like sun, they do not twinkle, but it is due to its apparent position, which is explained here. See, it is due to its apparent position that sometimes the light ray are coming to your eyes and sometimes not, and due to that change in the position, you get to see the twinkling of stars. Now, then another question takes place that some planets are very close to Earth. Why don't they twinkle? Right. The answer itself is there. Say, for example, this is Earth, and there is a planet which is which is very very close to Earth as compared to a star. So, for Earth, the star is just a point source. Only one ray, say for example, is coming because it is a point source. But for Earth, as it is very close to planet has many point sources in it. So, like, if at all one or two ray do not fall on your eyes, there are many other points which will make image in your eyes, and that will not make any difference to the image formed by planet on your eyes. And that is why it seems that planet never twinkle. It is very clearly the planets are much closer to the earth and are thus seen as extended sources. Extended sources means huge surface. If we consider a planet as a collection of large number of point source lights, collection of large number of point sources, the total variation in the amount of light energy entering our eye from the individual point source will average out to zero. So the deviation or the variation will be completely zero, thereby nullifying the twinkling effect. This is how it is formed. Another very important phenomena involved in this twinkling of in this atmospheric refraction is advanced sunrise and delayed sunset. See, suppose you are here and your horizon is this, okay, as it is written. So, if at all the sun is below your horizon, now the light ray which is incident, which comes from the sun, due to atmospheric refraction will bend and fall into your eye. So, ultimately, for your eyes, a straight path will be formed whose apparent image will be formed up. So, the sun will be visible to you before actually it rises up. The same thing happens when it sets down. When sun sets, okay, the sun has already gone down, but still due to atmospheric refraction, its apparent image is still visible to you. And there is a difference of 2 minutes in the whole process. Okay, so this is all again atmospheric diffraction. You can go through, see the sun is visible to us about 2 minutes before the actual sunrise and 2 minutes after the actual sunset because of atmospheric refraction. By the actual sunrise, we mean the actual crossing of the horizon by the sun. The actual and the apparent positions are of the sun with respect to horizon are shown in figure 11.10. The time difference between the actual sunset and apparent sunset is 2 minutes. The apparent flattening of the sun disk at the sunrise and sunset is due to the same phenomena. Okay, so this is how it all takes place. I will move into our next video with our new topic, that is scattering of light.